let's look at an example of constructing a Cartesian product. So let's take the Cartesian product of three sets. So first we need to define those sets. So we're going to let S, T, and U be sets. So our set S is going to contain the elements 1 and 2. Okay, and then T is going to be a set, and it contains the elements 3 and 4. And then U is a set containing the elements 5 and 6. Okay, and so we're interested in finding the Cartesian product of S, T, U in this order. Okay, so it's going to be the set of all three tuples or ordered triples, X, Y, and Z, okay, such that X is going to be an element of the set S, Y is going to be an element of the set T, and Z is going to be an element of the set U. Okay? So that's what our set's going to look like. It's going to be these three tuples or ordered triplets. So let's go ahead and enumerate these. So if we start out kind of a template, we're going to say that each of our triples is going to have these three things. And again, the first one is going to, let's call it X, and it's going to have the property that it's an element of the set S. And the second one's going to be Y, which has the property that it's of an element of the set T. And then our last one, Z, is going to be an element of the set U. Okay, so first thing that we're going to do, let's pick the first element of the set S. Okay, and then let's pick the first element of the set T. Alright, and then let's pick the first element of the set U. Alright, so this would give us our first ordered triple. Okay, 1, 3, 5. Now, keeping the first elements the same, let's take the second element of the set U. Alright, now there are no more elements from U to take to form triples, so let's, keeping the first element, the element from S the same, let's change the element from T, we're going to make it 4, and then taking the first element of U gives us 1, 4, 5, and then you can see the pattern that we're going to take here. Okay, so now we can't make any more triplets using 1 and 4, so, and we've exhausted all of the elements of the set T, so let's take a new element from S, we're going to take 2, and then we repeat. Okay, and now we have enumerated all of the possible triples. Okay, so now let's write this out in set format. So if we want, here's our set, it's the Cartesian product of STU. Okay, and it's going to contain these triples, so let's put those in. 1, 3, 5, 1, 3, 6, 1, 4, 5, 1, 4, 6, 2, 3, 5, 2, 3, 6, 2, 4, 5, 2, 4, 6. Okay, so there's our set. So we might ask the question, now that we have all of the elements of the set, is the triple 1, 5, 6 an element of the Cartesian product of STU? Okay, well, if it is, then it's the case that 1 must be an element of S, and 5 must be an element of T, and 6 must be an element of U. Okay, so is this true? 1 is an element of S, that's true. Is 5 an element of T? No. And is 6 an element of U? Yes. But since this was not true, then it's not the case that the triple 156 is an element of this set. Okay, so the question here, the answer would be no, that's not an element. So we notice that order matters when we're creating the cross product of sets.